based on this. All right, so the first thing is to construct a perpendicular to this longer chord originating from the center of the circle. So nice easy way to do that on your sketch pad is just select the center, select the chord, and construct a perpendicular. Okay, so there is our perpendicular. And I'll make it dashed to illustrate that. Okay, so what does this do to the chord? So if I find this intersection point, and I measure the distance between these pieces. So if I measure this distance, A to B is 3.59, B to, it'll probably label it C, is also 3.59. So it doesn't matter where I put this chord, what's always going to happen when you construct a perpendicular from the center of the circle, it's going to bisect the chord. Okay, so any perpendicular from the center of the circle will bisect the chord. Okay, so if I go back to this, so any perpendicular from the center of a circle to a chord will bisect the chord. And this perpendicular to a chord, so what we're told, or what we saw on Sketchpad, was that this perpendicular is going to bisect the chord, and this is referred to as the distance from the center. And so the distance from the center is just the perpendicular distance from a chord to the center. All right, so if we go back and we look at the second thing, or the second instruction, to construct a chord whose length is equal to the length of this shorter chord. Okay, so again, if we wanted to do that, the way that we can find a chord with that length is if we select a point somewhere on our circle, select the length of that chord, the smaller one, and then construct a circle by a given center, which is the point we selected, and the radius, which is the segment we selected. So that means I can choose to either create my chord from here to here or intersect these. So I'm going to choose this intersection and then connect those, and I'm going to turn this back into a solid line. Okay, so here is a chord that is the same length as this other smaller chord. Okay, I'm going to hide this guide that I used to draw it. How does its distance from the center compare to the distance of this original chord? So once again, let's find the distance is a perpendicular between or from the chord to the center. So if I construct that as a perpendicular, once again here I'll go back to the dashed lines. Okay, the same with this. Construct a perpendicular. Choose my intersections here. And so if I measure these two distances, so I find these 2 points, the center and the chord, for my example, have a distance of 47.3. If I compare that to these two, should be the exact same. Okay. Once again, no matter where I move these, again, those are dynamically tied, so as I adjust the size of this one stays the exact same, and their distances from the center also remain the same. Okay, so if you have two chords that are the same length, they're also going to be the same distance from the center of a circle. Okay, so that's the other or next relationship that we see here. So if you have congruent chords, they're going to be equidistant from the center of the circle. Right, so if I had, let's say, this chord and then a second chord with the exact same length, and I wanted to find or identify what is their distance to the center, those will also be equivalent. Right now, when you look or compare this shorter chord compared to this longer chord, what appears to be the relationship between them? The shorter the chord, is it closer to the center or further from the center? Again, we can see it here. So here's, if we find this distance, BD, to use as a comparison. Okay, so AC compared to, let's say, this length here. So if GH is 3.26, AC has a length that's the sum of those, so 9.2. Okay, the longer the chord, is BD closer, or is this a smaller distance from the center compared to the distance of GH? Yeah. So the longer the chord, the closer it is to the center of the circle. The shorter the chord, the further it is from the center of the circle. Okay, so that's the next property, is shorter chords are going to be further from the center. Okay, and then longer chords are going to be closer to the center. Now, that should make sense, right? What is the longest chord you can have in a circle? The diameter, and how close to the center is the diameter? It contains it, right? It's on that. So a distance of 0 is the longest chord you can have. So again, that should be pretty intuitive. And the longer the chord is, the closer it is to the center of the circle. Okay? So the properties, again, just to really quickly summarize these that you're going to be using. They'll probably be used a little bit more when we start the chapter on triangles, because we'll create some triangles from these intersections here. But the perpendicular from a center to a chord isn't just a perpendicular, it's a perpendicular bisector. So it is going to bisect the chord. And then the longer the chord, the closer it is to the center. The smaller the chord, the further it is from the center. Okay, so if we look at these three examples here, I'm going to talk through the first one, and then I'll have you do the second two here really quickly. But if you took a circle with chord MN that is a length of 7 units, and chord PQ that's a length of 8 units, which one of these is going to be closer to the circle, or closer to the center of that circle? PQ, right? So segment PQ will be closer because the longer the chord, the closer it is to the center of the circle. Example 2. If two chords are equidistant from the center of a circle, then what do you know about their lengths? They're also equal, right? So if we take the expressions that represent their lengths and set them equal and then solve, we can find our value for x. So here, if we move all our like terms to same sides, so we move our constants to the right, move our variables to the left, we get 7x is equal to 35. Solve completely for x, we get x is equal to 5. Now, is that our answer? No, we need to substitute this in to either of these expressions. They should be the same since we set them equal to each other. So probably the easier one is the one that involves the addition, not the subtraction. So if you were to substitute this in and test, 25 plus 11 is equal to 36. So you get your solution of 36. And now, the nice thing with algebra is it allows you to often verify your answers. So we can verify this by plugging x into this equation as well, or the expression. And we should get the exact same answer. So if we took 12 times 5, which is 60, minus 24, is that equivalent to 36? It is, so that allows you to confirm that you had the right answer. Okay, and then finally, question 3 is similar to the first question here. If you took chord AB, and it was given as being 6 units from the center of a circle, and chord GH is 3 units, so it is closer to the circle center. Which chord is going to be longer? The one that's closer to the center will be longer, so your answer would be GH.